Hello, welcome to this introductory video for SAMMI, a tool for drawing and visualizing metabolic networks. You can access SAMMI through that link right there, sammitool.com, and this takes to this page with all the tool information. You can launch SAMMI by clicking that button, and this is sort of the home page where you can load your model. In this video, we're going to be visualizing Recon 3D. You can download it directly from the big database. We're going to use a JSON file, but the XML file would do as well. Since Recon 3D is a very big model, it's over 10,000 reactions, we don't want to load them all at the same time. So we're going to parse the model into different subgraphs as we load them. So select Recon 3D and say, I want to make parse based on reactions and make a model for each subsystem. There are other ways to parse it. You can load models directly from CAG, but this is one of them. And this is what the graphs initially look like. They're sort of these interactive, force-directed layouts, and you can go through each subsystem that's annotated in the model. So for example, if we look at the citric acid cycle, these are all the TCA reactions annotated. These graphs are sort of connected. You can search between them. So for example, if I control-click and search for a node, I can see other subgraphs where the node is present. So for example, citrate here is also available in these other subgraphs. So you can click and it'll take you to the subgraph. And here you can see that same metabolite in a different subgraph. Go back to CA cycle. Alternatively, you can also select a node and highlight it, and that'll show you all the reactions where that metabolite is present. So here are the TCA cycle ones, and there's all these other subsystems, and you can go to them and visualize the reaction. Sorry, I clicked out of it. So again, let's go back to our TCA cycle. You can make copies of different metabolites. So for example, you can either break it and make a copy for each reaction is present. You can join those back. You can make just a second copy for any other reactions that they're selected. So for example, now I made a second copy of this metabolite, and it's associated with the other reactions that I had selected. So there's a lot of functionality like that to split metabolites. Another one you can do is you can shelve them. You can do them one at a time. I'm not deleting these. I'm going to explain where they're going. But you can also upload a file. So this is a file of a bunch of regular expressions, and any metabolite matching any of these regular expressions is going to get shelved. So here, low metabolites to shelve, secondaries open, and so now you can see the major metabolites a lot better. This gets trickled down to all other subgraphs as well. And you can put these metabolites back. Come down here, shelve metabolites, either one at a time, or you can put them all back at once. And so this will allow you to sort of clean your graph a little bit while you arrange other nodes or do whatever you want to do, but then put the secondary metabolites back. You can arrange nodes different ways. So for example, I select these two nodes, find different paths. Here I'm going to find the smaller circle between them. And then arrange them in a circle. You can, scale their location. You can rotate them however you want. So there's a lot of functionality for that. You can upload data. This is just a tab delimited file. It has reaction IDs and then different conditions. If I go here, I'm going to upload it as reaction caller. Now the nodes are all colored. You can change the color scale, and that all gets reflected immediately. You can make the color scale global, so apply that to all different conditions, and then you can parse these conditions and see how the colors change. Similarly, you can load the size data, so we're doing for metabolites and size data. Same is just a tab delimited file. And now you can see different metabolites are going to have different sizes. And again, you can change that scale here. You can refer to the documentation for how these work. You can download a PDF of your visualization. I'm going to replace the previous one I had downloaded. Go here to my downloads. And now you have a PDF of exactly what you were looking at with the color scales and everything. You can also download a SAMMI specific format that's going to save all the data and everything, all the null positioning and everything that you can share with people, and also files compatible with Asture and MetaExplore Viz. The last little bit I wanted to notice is we also develop plugins for MATLAB and Python, and those allow you to load maps directly from within these two programming languages. So for example, if I go here, or in Python, I imported Cobra for the models and NumPy for a couple of the examples, but this import SAMMI is what allows you to work with SAMMI directly from within Python. And if you run this little bit, just plot a small model, you can look at all different reactions. It's going to load an HTML file. They can get more complicated. Now down here, let's see, load model with these are the reactions that you want to load and some data associated with them. And you can get basically a lot of the same functionality. You just can't upload data that will be uploaded directly, from Python, and you can't download PDFs or anything, but you can download a SAMMI format and then go upload this exact same graph in the web platform for SAMMI. Similar thing from MATLAB. Here, for example, just get the Cobra directory, load a model, and then load these reactions that I want to learn. So if you run this little script, all this is going to do is open an HTML file. And you can look at the documentation for both of these. This is the MATLAB plugin. There's a bunch of examples here that you can run. Same thing for for the Python one. And again, sammitool.com, and you can see all the different documents. And any bug reports or any recommendations of anything, please visit us on GitHub, submit an issue, and we'll get back to you. And that's SAMMI. Hope you enjoy. Thank you very much.